Welcome to Module 6 on supernovas. Supernova is the explosion of a star, and it is easily one of the most spectacular events in the entire history of the universe. Supernovas have been happening for the last 12 billion years, and they are the way in which the universe creates chemical complexity at the level of elements. So I just wanted to go through some of this with you to give you an overview of it. The star we talked about before, using hydrogen in its core, will be burning for something like 1,000,000 years. So during that 1,000,000 years, if it's a certain size star, it will cycle through more slowly. It'll take it 10 billion years. But during that first period, the hydrogen is being transformed into helium because the center of the star is 15 million degrees. So you imagine this hydrogen it's being fused into helium, it's releasing its energy, and it's maintaining this dynamic equilibrium of the star. But after a while, all of the hydrogen in the center is used up. And so you have this sudden dropping off of energy released in the center. And so now gravity is pulling in very strongly, and so it pushes the star down. The star implodes a bit. And as it implodes, the temperature soars in the middle until it reaches a level where even helium can be burnt. So helium can be fused into carbon. And so then once again, so you have this collapse of the star, and then suddenly, bang, the helium takes off and creates carbon, and so we have this release of energy, and once again we have this dynamic equilibrium. And this would carry forth for something like 1,000 years. But then again, the helium is used up, and so you have now a further collapse of the star, and you get to a point where the carbon begins to burn. Now, as the carbon starts to burn, we have a layered effect in the star itself. I mentioned before that the hydrogen was burned up, but that's the hydrogen only in the core. There's still hydrogen in the outer envelope of the star, so that you'll have an onion effect. You've got hydrogen out here, then you've got a new layer of helium away from the core, and now we have the emergence of carbon showing up through this new fusion event. And once the carbon is used up, it soars off again in heat, and you have the creation of oxygen, and so forth, until you get up to iron. When you get to iron, you have a major reversal moment in the universe, because iron cannot burn. Iron can be fused for sure, but it requires more energy than it releases. So you have, at this point, you have the different layers of the elements, and the iron starts to show up in the middle, and it does not provide energy to hold out the collapse. So this whole process now has taken, depending on the size of the star, several billion years. But at this point, it's come to an end, because now nothing can stop the collapse of the gravitational pressures. And you have a star, after burning for these several billion years, collapses down to a point. The inner core collapses down to a point in just a matter of seconds. And this is what we mean by the supernova implosion at this point. This would be the complete picture of death, because every possible structure that has been created, I mentioned the hydrogen, the helium, the carbon, the oxygen, all of that structure is completely crushed in the collapse of the star. And the great surprise is that the collapse doesn't end there. This is one of the most dramatic surprises in the history of the universe. The existence of another particle called a neutrino, which is extremely subtle. the neutrino has the power to actually blow apart this explosion. It can't be trapped. Neutrino, the probability of a neutrino encountering even another particle in an entire light year of lead is less than 50%. So if you took 6 trillion miles of lead and you sent a neutrino from one end forward, it would have a very good chance of going through the entire 6 trillion miles without encountering a single particle. That's how elusive this particle is. But with the star all collapsed down so densely, the neutrino can interact and actually sends the material of the star out. It blows apart the collapse. And in that now new expansion, all of the elements of the universe are created. So the helium, the hydrogen, the carbon, the oxygen, the silicon, the neon, all of these elements are given birth to in this amazing event, which is so brilliant. It is the same intensity as an entire galaxy for a day. It has the intensity of 100 billion stars. That is the death and rebirth action of the supernova explosion. I use the phrase death and rebirth because there's a way in which this story of the supernova relates to some of the fundamental mythic stories of our planet, and the so-called the hero, the story of the hero, which is shown up in culture after culture. It goes through a very particular sequence, such as this. The start of the story is paradise. It's with the family. It's where everything is wonderful. And then something happens to remove the hero from the paradisal state. There's an expulsion moment or a fall. And then suddenly the hero is thrown out into the world where there are enemies and friends. And there's a series of challenges before the hero. And then there's the death, the culmination of this whole event where there's the final death, but it ends in a rebirth of the hero. And the rebirth is a return to the larger community with the great boon. It's the gift the hero comes back with. So this sequence, which has shaped the cultures around the planet, shows up in this amazing story of the supernova. Because we start off with a stable state, that's a home state. And then the star, burning hydrogen, the star is thrown out of that state. This is now the star as the hero. And suddenly it's expelled from a previously paradisal equilibrium. Everything was working, the star was shining. And then it goes through these series of challenges where the star eventually finds itself unable to escape, and it goes through this collapse. And then we have the rebirth. And the rebirth of the supernova explosion is what enables the rest of the universe to complete its journey. So that we're here now, and we're loaded with all of these elements, so phosphorus and oxygen and carbon. Every one of them was shaped by a supernova explosion. Without exception, there isn't a single large atom in your body that was not shaped by a supernova explosion. So it's the sense of the universe having this deep, heroic archetype, or the heroic mythic journey. Now we see it not though in the form of a human, but in the form of the stars themselves. We see the stars themselves involved with a creative process that enables all future life to exist. In the real sense, we're participating in that same process.